Hello, can you hear me? All right, my name is Marcus Whelan. I'm a software development engineer at Park Energy Services, and this is TeDB ecosystem. Myself and Travis Sturls. He works in Colorado at Metis Machine, and we wrote a JavaScript database, kind of like a DBMS, sort of. But let's get into it. I gave a talk about this at JavaScript Talk, I think about 2 months ago. Here are just what we went over that talk, problems and solutions. Kind of like how you had the IndexedDB used on this, like the web browser. We decided to write a Electron application that we could just download on our clients, like actual desktops. But we didn't want to have any binaries, so we didn't want to use SQLite. We didn't want to use any like smaller MongoDB items or anything with binaries. We just wanted to have an npm install, get that database going, have it embedded, have it write straight to the disk. There were other options out there like NEDB, or like Loki.js, or those are some of them just in memory. But NEDB was actually would write to disk, but the problem was it would hold the entire objects in memory, which became a problem because we were dealing with larger databases, and so that would just crash our little client computers. So we had to come up with a new system, and that's where we came in and wrote our own, like we would save just the ID in memory, and the ID would reference the object on disk, and then you would just pull the object out whenever you needed it. The actual storage driver isn't stuck on TeDB. It's actually a separate open source project, so you can write a different storage driver for it. So if you want to have one specific for Linux, one specific for Mac, one for React Native or something like that, or Raspberry Pi, you can write your own storage driver for it. The problem right now I have is that I don't have enough time to write all these storage drivers, so it's kind of like an open source, hey guys, you want to help out kind of thing. I wrote a Electron one, of course, because we needed it for our actual company, and that it should work on Linux. I'm not sure, I haven't tested it. I've tested on Windows and Mac, and that works just fine. Here's some little bit of speed. Inserts IO restricted, because I have it separated to where each create is a new file in a directory, so you can have multiple reads and writes at the same time without bottlenecking on a file. So we have 100K objects, inserts 106 milliseconds, find 1 to 4 milliseconds with an index. As you can see, you can look at the rest of these. Pretty fast for what we're doing. We don't need that much speed, but it was great when we found out it was fast. So TeDB.org, or just our organization on GitHub, we have the binary type tree, which I wrote. It's kind of like a fork from the AVL tree written for NEDB, but we took out the ability to index nothing, which was kind of an issue because indexing nothing really didn't help very much. TeDB, which was written by myself and Travis. TeDB utils written by myself for all the util functions. I decided to break those out since they were so useful. I decided I wanted to use them in many different places because I tested them against hundreds of other algorithms and I found out these were faster. TeDB Electron Storage is the storage driver for it, and more is more like what we were wanting, some more people to get involved with TeDB since it's really fast and I really want to do more with it. And I haven't gotten the full MongoDB, like all their queries, how they can do like exists and all those things. So I only have a couple. I have greater than, less than, not equal to, all the basic things. All right. It is written in TypeScript, which is, I find, really a huge benefit because JavaScript for me is kind of just like this, just there, and then TypeScript kind of gives it its whole body and life to like, hey, there's types now, you can understand what's going on, you can make an interface for this class, and then you can see, like if someone else's project, you pull it in and you can just type and get a completion, like, hey, this class is this, and it has these options, instead of kind of guessing, or going to read their documentation, you can just auto-complete it right there, if you have the right IDE, of course. Let's see, custom search creation. Oh, okay. So with the class creation for each object, I'll show you here in a second. And promise-based, the whole thing is promise-based, so it's not synchronous. It's all asynchronous, like maneuvers through data. So you don't have any. That's why I try to make it where you don't bottleneck on something. One file I haven't gotten to, but like AnyDB for their browser system, they used IndexedDB. And so IndexedDB would be a good option to write a storage driver for the browser, but I haven't done that yet. We haven't needed it yet. So here is some code examples. If I can pull, oh, yeah, there we go. All right, so you can't see that very well? All right, so here's Typescript Interface. You got question marks means it might be there, it might not. If there isn't, it has to be there. So it's kind of like creating our own schema without having like Mongoose or other library. You just have TypeScript. And then whenever you try to make an object, that has to be there. Let's go to, here's the actual database. It's like the actual collection. And here you can have events that are actually made into promises. So you just fill them out when you make a new object, and then you can hand off promises like here, with a save, event, pre-save, and then you would put in your actual function in this place. So here I have post-sync, and I've got a method called post-sync flat. But if you had pre-save, you could put your own method there, and that's a different global method I wrote just for that specific part. But you can see how you have just a file open, you make your collection, and then every time you ask for this, you ask for it. And if you don't have the index, you just hand it back off. If you don't, like let's say your app's just loading up, then it loads in your index and loads in, it sets all the indexes. Another thing we did was we didn't make it to where the database would load the index from all the file, like all of it at once, right on startup, which is kind of slow. We took the index and saved it into like a list, a quick list, and saved it as JSON, and then just load that up, which makes it really easy and load really fast. Let's see, let's exit this. And oh no, I played from start. All right, that was the last slide anyways. All right, so if you have anybody have any questions or you want to get a hold of me, yeah, I can email myself. Don't save. God, okay. So yeah, here's my email. I'm also on Slack a lot. I have it open all day. So if you want to get in contact with me, I'm always available. Also, if you have any questions about just TypeScript in general, I really like talking about TypeScript and how useful it is. Anybody have any questions about TeDB or any uses? All right, I'll let you guys go. Okay.